Hello and welcome. In this video, we're going to take a look at the layered architecture that we're going to leverage when we do our web and internet development. The purpose of this video is to sort of look at the justification for a layered architecture and to take a look at two common models, one of which we are going to use throughout this series to demonstrate the principles behind layered architecture and the different layers, or rather the purpose of each of the layers. And so to begin with, what we want to do is we want to understand why we need a layered architecture. And so there's two reasons, really. One is that it provides for an ability to connect between dissimilar hardware and software systems, allows for that communication. And so to help you understand why we would need something like this, well, why does it really matter, for instance, if you are dealing with a Linux operating system on a Dell hardware, or perhaps a Windows operating system on HP hardware? Well, the answer is it probably doesn't. And likewise, on the client, it doesn't matter whether you're running necessarily an Android operating system, Microsoft Windows operating system, or an Apple operating system. Instead, what the layered architecture provides is a common mechanism for the communication between these dissimilar systems. The second reason that we're interested in a layered architecture is because it provides an abstraction between the layers. And so if you think of this as a block, or series of blocks, or a series of layers, then with the lowest layer being at the bottom and the highest layer being at the top, then essentially as you go up the stack or up the layers, then you would expect to get higher levels of abstraction. Put another way, once you're at the top layer, you don't necessarily know how the bottom layer works, or for that matter, you arguably wouldn't need to know how the bottom layer works. Now, we're going to take a look at two different models, but before we get to that, let's sort of understand some other examples. And also, what is the key to the layered architecture is this reliance on standards and protocols. And particularly what we're going to do is we're going to focus on a few standards as they relate to HTTP, which is our web client and web server traffic, although there are other protocols and standards that we would be interested in. And so some other reasons or some other justifications, just so you can appreciate this, is should your computer hardware be used to determine how your web browser behaves? Well, not necessarily. And so a good example where it might matter is if you are on an Android tablet or a iOS tablet and your screen size is limited as opposed to a desktop with a nice large monitor, then you could argue that yes, your behavior of your web browser does matter depending on the type of device that you're on. But besides that, you would expect for the experience to be relatively similar, especially when you have the same web browser on two different clients. The next example is you want to think about, should the switch that you are connected to necessarily care what type of hardware you are using? Well, the answer is probably not. Now, obviously, if it's wireless versus wired, there's going to be a little bit different things going on with respect to the networking. But fundamentally, that is, once again, another reason for this layered architecture, this abstraction, in that at that layer, it shouldn't necessarily know what the operating system is, or even for that matter, what application that you're using. Now, there are some minor details and some examples that I'm ignoring here, but fundamentally, the answer to this is no. And then lastly, should the web server care what web browser you are using? Well, once again, the answer is probably not. And so, for instance, if you are using an Apache web server on a Linux machine or IIS on a Windows machine, the behavior of the client, whether you are on a Apple using a Safari, or if you're using Chrome on any of the devices, or for that matter, Microsoft Edge, the browser experience should be relatively similar through any of those common browsers. And the reason, or the way that this is leveraged rather, is because of the standards. The idea is the modern up-to-date browsers all should behave similar or behave in a standardized way. Now, that wasn't always the case. In other words, you used to actually see some differences between how Firefox and Chrome, or Firefox and the earlier version of Internet Explorer would behave. However, though, the purpose of the standards, though, is to eliminate the differences between the experience or the end user experience for these different browsers. Now, how is that facilitated? Well, there's two main models that we will take a look at. We're going to focus mainly on the first one, the Internet Protocol Suite, or the IP model, but the second one is going to be the Open Systems or Interconnection model. And so to begin with, let's take a look at the IP model. There's 4 layers. The first layer is the application layer, and we're going to focus mainly on HTTP and FTP for the purposes of this series, although we are going to spend a little bit of time with DNS being our domain name system. HTTP, of course, is our hypertext transfer protocol that we use between our web server and our web client. FTP is going to be your file transfer protocol. And then we could also look at our mail clients, although that is not a focus for this series. Now, below that is going to be the transport layer, and our application layer communicates with the transport layer. And in the transport layer, that is going to control things like the connection and connectionless oriented communication between a client and a server. Now, for our HTTP, primarily, we're going to leverage TCP or connection-oriented services, because usually what you have is you have the idea of a web server listening and establishing a connection, although that is not a requirement for HTTP. Hence, once again, the benefits of this abstraction of the layers. And so the boundary then between the application layer and the transport layer then allows for this abstraction. Layer down then is going to be the internet layer, which focuses on the addressing. We have 2 predominant schemes here, and that is IP version 4 and IP version 6. We're going to focus primarily on IP version 4 so that we get a good understanding of how it works. But effectively, then, the internet layer with the IP addresses combined with our domain name system services will allow for you to be able to put in a friendly name in your web browser, for instance, www.facebook.com, www.uab.edu, and so on, and have that mapped back to an IP address. Once again, we're not going to focus too much on the basics behind networking, just so you can sort of appreciate then how these layers work. And then the lowest layer that we're going to be interested in is going to be the link layer, and that is literally the physical layer. In other words, you can almost think of this as the basic circuitry behind how the internet works. And the predominant or the most important feature of this layer that we're going to be interested in is going to be the MAC address. And so for each one of the network cards, whether it is a physical Ethernet connection or a wireless Ethernet card, they will have a unique MAC address associated with it, unique hardware address. Then combined with the IP addresses will allow for you then to communicate from one device to another, whether they are ultimately on the same network or on other sides of the world. The OSI model is essentially an extension of the IP model. It has 7 layers associated with it. And once again, we're not going to focus quite as much on the OSI model, but the main thing that you want to notice is that the coloration between the 7 layers and then the 4-layer model that I have on the right side, you'll see that the application, presentation, and session layer are combined in the OSI model into the application layer on the IP model. And so effectively that abstraction, in other words, that your web client doesn't necessarily know how the traffic actually gets over to the web server. Essentially, it just thinks it's magic. And likewise, the application layer focuses on the communication back from the web server back to the web client, doesn't necessarily know how that traffic is actually communicated on the physical network. Once again, that's the benefit of this layered architecture. Below that is the transport layer, which is functionally the same between the two, simply provides a means of transferring the variable length data sequences between the nodes on the network or the client and server. The network layer is what's actually responsible for transferring the packets between the nodes. Once again, the network layer and the internet layer focuses on that IP addressing. Functionally, they are very similar in these models. And the last set then is going to be the data link and the physical layer, which combine to the link layer in the 4-layer model. With the key thing here is that the data link layer focuses on the correction and the management of the errors in the communication between the client and the server. Communication between those two will not necessarily be perfect. And so at the hardware layer, then that can be corrected through the data link or through protocols in the data link and the physical layer. And the physical layer, of course, focuses just on that unstructured raw data. You can literally think of that as nothing more than a very, very large and sophisticated circuits problem. So continuing on with that, how do we combine this and leverage this into our understanding for our web development? You can see on the left-hand side, we have the application, transport, internet, and link layer from the 4-layer model. We want to think of that then as our client. And on the right-hand side is going to be our server. Communication is initiated at the application layer, communicates down to the transport layer, internet layer, and link layer. Remember now, as we go down, we're going to get more primitive. As we go up, it's more abstract. So the application layer doesn't necessarily know how the actual bits are going to be transferred. It just knows to pass the information down the stack through the Ethernet, through these layered networks where we may have multiple switches. We will have an internet service provider, an internet exchange point if you're going across country or across to another continent. And then on the other side of that, there will be another Ethernet or network then that communicates the information through the link layer up to the internet layer, transport, application layer. On the right-hand side, we would want to consider that our web server. Our web server then simply responds back to the request made by your web browser or web client, communicates the information back down the stack through the Ethernet or through the network, its local site, through these layered networks, over then to your network and back up to your web browser or your application layer. Now, you'll notice I have the red dashed lines between the two application layers. And so if you think about it, your web browser doesn't really know about anything that's going on below it. It just thinks it's a virtual connection to your web server. So for instance, you go into your web browser, you put in www.uab.edu. There's essentially a virtual connection going on between the web client and the web server. Likewise, this happens at the transport layer where you have a virtual connection between your web client and your web server. It, however, still goes down the stack and up the stack, down the client stack and up the server stack and vice versa. It's just, it appears because of these protocols and because of these abstractions, it appears to be a virtual connection. So what are we really interested in? We are interested in 4 main protocols when it comes to web development and internet development in general. That is going to be our HTTP or hypertext transfer protocol that focuses mainly on our web browsers and web servers. However, that's not exclusively used there. It can be used elsewhere. As we saw in another video, there are similar systems with XML and HTML, SSH, which is a secure shell or a means of communicating securely between dissimilar systems, is, for instance, used in system administration and remote computing. FTP or file transfer protocol is a basic way of uploading and downloading files, can be oftentimes used in conjunction with a web server to provide a backdoor means for web development. We are not going to focus as much on the email related protocols. We just want to be familiar with them. And those are going to be things like our POP or post office protocol, IMAP, which is our internet message access protocol, and then SMTP, which is our simple mail transfer protocol. And basically what's different between these is simply whether they require a connection or a connectionless communication, as well as how they choose to store and relay the messages. So once again, we're not going to focus too much on that in the series. But the last one that we're going to be interested in is going to be this domain name system, which essentially allows for a mapping between the friendly names, for instance, www.uab.edu or www.facebook.com, to the IP address associated with the server or services that provide them the service. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to email me, and thank you for watching.